Long spring is stretched by 2 centimeter and its potential energy is V. If the spring is stretched by 10 centimeter, its potential energy will be. Here are the options. Now let the new potential energy be V dash. Therefore, potential energy is given by PE is equal to half into K into x square. Therefore, V dash upon V will be equal to half K into x dash square upon half K x square, which will be equal to 10 into 10 upon 2 into 2, which is 25 volts. Therefore, here the correct answer is option B. What is the energy stored per unit volume in a copper wire of uniform cross section and length 1.5 meter when it is stretched to a length of 1.51 meters by a stress of 3 into 10 raised to 2 Newton per meter square? Here are the options. Now the energy stored per unit volume is given by the formula half into stress into strain, which is equal to half into 3 into 10 raised to 2, and the strain is given by 0.01 upon 1.5. So on calculating we'll get the answer as 1 joules per meter cube. Therefore the correct answer here is option D. A ball falling in a lake of depth 200 meters shows a decrease of 0.1% in its volume at the bottom. What is the bulk modulus of the material of the water of the ball? Here are the options. Now the bulk modulus is given by K is equal to V change in the pressure upon change in the volume, which is equal to dP dV upon V. Now the change in the pressure, the formula for change in the pressure is rho into G into H. Now rho is density of water is given as 100 kg per meter cube. Therefore 1000 into 9.8 into 200, which is equal to 19.6 into 10 raised to 5. Therefore the bulk modulus will be given by K is equal to 19.6 into 10 raised to 5 upon 10 raised to minus 3, which is equal to 19.6 into 10 raised to 8. Therefore the correct answer here is option B. Wire of length 3 meters and diameter 1 millimeter is stretched so that its length increased by 2 millimeter. What is the decrease in the diameter of the wire if the Poisson's ratio of the material of the wire is 0.36? Now Poisson's ratio is given by the formula Poisson's ratio into the change in length upon the original length into d. Now we know that Poisson's ratio is 0.36, and the change in the length is 2 into 10 raised to minus 3 meters upon the original length was 3 meters into the diameter is given by 10 raised to minus 3. Therefore, on calculating all this, the value we get as 2.4 into 10 raised to minus 7 meters. Therefore, here the correct answer is option B. The increase in length of a wire on stretching is 0.04%. If its Poisson's ratio is 0.5, the diameter is reduced by A 0.01%, 0.05%, 0.04%, or 0.02%. Now the change in the length thereby L upon L is equal to 4 upon 100 into 100, which is equal to 4 into 10 raised to minus 4. Therefore the change in diameter D upon D will be equal to Poisson's ratio into delta L upon L. Poisson's ratio is 0.5, which is half into 4 into 10 raised to minus 4, which is 2 into 10 raised to minus 4. Therefore the change in the diameter will be equal to 0.02 upon 100, which is 0.02%. Therefore the correct answer here is option D. A wire having a diameter of 3 mm is stretched by an external force to produce a longitudinal strain of 3 into 10 raised to minus 3. If the Poisson's ratio of the wire is 0.4, the change in the diameter is, here are the options. Now the Poisson's ratio is given by the change in the diameter upon the change in the length. Therefore, the change in the diameter upon the original diameter will be equal to the Poisson's ratio into the change in the length upon the length, which is equal to 3 into 10 raised to minus 3 into 0.4, which is equal to 12 into 10 raised to minus 4. Therefore delta D upon D will be equal to 12 into 10 raised to minus 4. Therefore D goes on this side. We'll get delta D is equal to 12 into 10 raised to minus 4 into D. Now the diameter of the wire is given as 3 millimeters, which is equal to 12 into 10 raised to minus 4 into 3 into 10 raised to minus 3. On calculating, we'll get the answer as 3.6 into 10 raised to minus 3 millimeters. Therefore, here the correct answer is option B. Aluminum rod with the Young's modulus as 7 into 10 is to 9 meter Newton per meter square has a breaking strain of 0.2%. The minimum cross-sectional area of the rod in order to support a load of 10 is to 4 newtons is, here are the options. Now the Young's modulus is given by Y is equal to stress upon strain, which is equal to F upon A upon strain, which is equal to F upon A into strain. Now here we have to find the value of the area A. Therefore A is equal to F upon Y into strain. We know the value of F, which is 10 raised to 4. We know the value of the Young's modulus, and we know the value of the strain which is given. Therefore, on substituting the values, we get the answer as 7.1 into 10 raised to minus 4 meter square. Therefore, here the correct answer will be option B. Are having Young's modulus 1.2 into 10 raised to 11 Newton per meter square is subjected to the stress of 2.4 into 10 raised to 7 Newton per meter square. If the length of the wire is 10 meters, the extension produced in it is A 2 millimeters, B 1 millimeter, C 3 millimeter, and D 0.5 millimeters. Now we know that Young's modulus is given by Y is equal to stress upon strain. Therefore, strain will be equal to stress upon Y. We need to find the value of the elongation produced. Therefore, we first calculate the value of strain, which is equal to 2.4 into 10 raised to 7 upon 1.2 into 10 raised to 11, which is equal to 2 into 10 raised to minus 4. Therefore, the elongation produced E will be equal to 10 into 2 into 10 raised to minus 4, which will be equal to 2 into 10 raised to minus 3, which is 2 millimeters. Therefore, here the correct answer is option A. Of 10 kg is suspended from a copper wire of length 3 meters and diameter 0.4 millimeter. Its length increases by 2.4 centimeter. If the diameter of the wire is doubled, then the extension in its length will be A 4.8 centimeter, B 0.6 centimeter, C 2.4 centimeter, and D 1.2 centimeters. Now we know that the elongation is inversely proportional to the radius square. Therefore, suppose this is E1 and R1. Therefore, E2 upon E1 will be equal to R1 square upon R2 square, which will be equal to 0.2 upon 0.4 the whole square, which is equal to 1.1 by 4. Therefore, the extension produced E2 will be equal to E1 upon 4, which is equal to 2.4 upon 4, which is 0.6 centimeters. Therefore, the correct answer here is option B. What pressure should be applied to a lead block to reduce its volume by 10%? Bulk modulus of lead is 6 into 10 raised to 9 Newton per meter square. These are the options. Now the bulk modulus is given by K is equal to V dP upon dV, which is equal to dP upon dV slash V. Now we know the bulk modulus, we also know the decrease in the volume. Therefore, to find out the decrease in pressure, yes, but to find out the change in pressure, we get dP is equal to K into D into dV upon V, which is equal to 6 into 10 raised to 9 into 10 upon 100, which is equal to 6 into 10 raised to 8 Newton per meter square. Therefore, here the correct answer is option C. A centimeter cube of a substance has its upper surface displaced by 0.5 centimeter by a tangential force of 0.25 newtons. What is the modulus of rigidity of the substance? Here are the options. Now the theta is given by the displacement upon the original length, 0.5 into 10 raised to minus 2 meters upon 5 into 10 raised to minus 2 meters, which is 0.1. Therefore, the modulus of rigidity will be equal to F upon A into theta, which will be equal to 0.25 upon 25 into 10 raised to minus 4 into 10 raised to minus 1, which will be equal to 1000 newtons per meter square. Therefore, here the correct answer is option D. The area of cross section of a steel wire is 0.1 centimeter. If the Young's modulus is given by 2 into 10 raised to 11 Newton per meter square, then the force required to double its length is given by A 2 raised to 10, 2 into 10 raised to 10, 2 into 10 raised to 12, 2 into 10 raised to 11, and 2 into 10 raised to 6 newtons. Now here the strain is given by L upon L, which is 1. Therefore, the force required will be F is equal to A into Y. Area of cross section is 0.1 into 10 raised to minus 4 into the Young's modulus 2 into 10 raised to 11, which is equal to 2 into 10 raised to 6 newtons. Therefore, here the correct answer is option D. Wire suspended vertically from one of its end is stretched by attaching a weight of 20 newtons to its lower end. If its length changes by 1% and if the Young's modulus of the material of the wire is 2 into 10 raised to 11 Newton per meter square, then the area of the cross section of the wire is, here are the options. Now the Young's modulus is given by Y is equal to F into L upon A into small l. Therefore, you have to find the area of cross section. A will be equal to FL upon YL. Therefore, here we know that the force is 20 newtons, the length is 100 upon 2 into 10 raised to 11, which will be equal to 10 raised to minus 8 meter square, which is 10 raised to minus 2 millimeter square. Therefore, here the correct answer is option C. On applying a stress of 20 into 10 raised to 8 Newton per meter square, the length of a perfectly elastic wire is doubled. The Young's modulus of the material of the wire is, here are the options. Now, the Young's modulus is given by Y is equal to stress upon strain. Now, here the strain will be equal to L upon L, which is 1. Therefore, since the strain is 1, Young's modulus will be equal to stress upon 1. The stress is 20 into 10 raised to 8 Newton per meter square. Therefore, here the correct answer will be the stress, which is 20, which is option A. Steel, the strain at the breaking point is 0.15. If Young's modulus for steel is 2 into 10 raised to 11 Newton per meter square, then the stress at the breaking point is A 2 into 10 raised to 10, B 1.5 into 10 raised to 10, C 3 into 10 raised to 10, and D 5 into 10 raised to 10. Now, we know that the Young's modulus Y is given by Y is equal to stress upon strain. Here we know Y is equal to 2 into 10 raised to 11 and we know that the strain is equal to 0.15. Therefore, in order to find stress will be equal to Y into strain. We multiply these two values and the answer that we get is 3 into 10 raised to 10 Newton per meter square. Therefore, the correct answer here is option C. The modulus of a metal is 8 into 10 raised to 9 Newton per meter square. The pressure required to reduce the volume of a spherical ball of that metal by 5% is, here are the options. Now the bulk modulus K is given by V into dP upon dV, which is equal to dP dV upon V. Now we have to find the pressure applied. Therefore, P will be equal to K into dV upon V. Now K is given as 8 into 10 raised to 9, which is equal to 8 into 10 raised to 9, and the change in the pressure is given by 5%, which is equal to 5 upon 100, which will be equal to 4 into 10 raised to 8 Newton per meter square. Therefore, here the correct answer will be option B. A tangential force of 0.25 newtons is applied to a 5 centimeter cube to displace its upper surface with respect to the bottom surface. The shearing stress is A 10 newton per meter square, B 50 newton per meter square, C 75 newton per meter square, or D 100 newton per meter square. Now the shearing stress is given by the force applied into the area upon the area, which is 0.25, which is 25 into 10 raised to minus 2 upon the area, which is the side square, which is 5 into 5, 25 into 10 raised to minus 4, which is equal to 100 Newton per meter square. Therefore, here the correct answer will be option D. The stress strain graph for two metals A and B are shown in the figure. Here are the graph. Now, which of the following statement may be true? Now, because Young's modulus Y is equal to stress upon strain, for the same strain, stress is more for A. Therefore, since stress is more, Young's modulus of A will be more than Young's modulus of B. Therefore, the first option A is wrong. This is wrong. Now, let's see option C. In option B is more brittle than A, which is actually true because the breaking occurs just after the elastic limit and the plastic deformation is the breaking occurs just after the elastic limit, which is in B, and the plastic deformation is very small. Therefore, B is more brittle than A. So if B is more brittle, A is surely not correct and D is also wrong. Therefore, here the correct answer will be option C. Between the elastic constant y, k and the Poisson's ratio is given by, here are the options. Modulus of rigidity, here are the options. Now, the relation between the Young's modulus, the bulk modulus and the modulus of rigidity is given by 9 upon y is equal to 1 upon k plus 3 upon eta. Therefore, on multiplying both sides, we'll get eta plus 3k upon k eta. Therefore, y will be equal to 9k into the modulus of rigidity upon plus 3k. Therefore, here the correct answer will be option A. Wire of length 1 meters, cross-sectional area 10 is to minus 6 meters, and negligible mass is kept on a smooth horizontal table with one end fixed. A ball of mass 1 kg is attached to its other end. If the wire and the ball are rotating with an angular velocity of 100 radians per second, the wire breaks. What is the breaking stress? Now, here are the options. Now, the breaking stress or breaking force is equal to F, which is equal to the centrifugal force, which is m into r into omega square. Therefore, the breaking stress is equal to F upon the area, where the force is m into r into omega square upon the area. Therefore, on substitute the values 1 into 1 into 100 into 100 upon 10 raised to 6, which is equal to 10 raised to 10 Newton per meter square or pascals. Therefore, here the correct answer will be option B. Rod breaks when the strain produced in the rod is 0.2%. What should be area of the cross section to support a load of 10 raised to 4 newtons if the Young's modulus of the material of the rod is 7 into 10 raised to 9 Newton per meter square? Here are the options. Now the Y is given as the breaking stress upon breaking strain. Therefore, the breaking stress is given by Y into the breaking strain. Now Y is given as 7 into 10 raised to 9 and the breaking strain is 0.2 upon 0.02%, which is 0.2 upon 100, which is equal to 1.4 into 10 raised to 7. This is the breaking stress. Now, breaking stress is equal to breaking force upon the area. Therefore, the area will be breaking force upon breaking stress, which is equal to 10 raised to 4 upon 1.4 into 10 raised to 7, which is 7.15 into 10 raised to minus 4 meter square. Therefore, the correct answer will be option A. Two steel wire of the following dimension are stretched with the same force. Which one of them will have the longest extension? Here are the options. Now the extension E is given by mgl upon pi r square into y. Now neglecting everything, for same y and mg same, we get E is inversely proportional to 1 upon r square. Therefore, if the radius is small, the extension elongation will be more. Therefore, out of all the 4 options, A has the smallest radius. On calculation also, we'll get the longest elongation of A. Therefore, here the correct answer is option A. Wire has a Young's modulus Y and energy density E. The strain in the stretch wire is A root of 2E upon Y, B root of B 2E upon Y, C 4E upon Y, and D root of E upon Y. Now the energy density E will be equal to half into the Young's modulus into strain square, which is equal to half into 1.1, which is equal to strain the whole square is equal to 2E upon y. Therefore, the strain on taking square root on both sides will get strain as 2E upon y. Therefore, here the correct answer will be option A. Body of mass 1 kg is attached to one end of a wire and rotated in a horizontal circle of diameter 40 centimeter with a constant speed of 2 meter per second. What is the area of the cross section of the wire if the stress developed in the wire is 5 into 10 raised to 6 newtons per meter square? Now the force, these are the options. Now the force which is given by the tension, which is equal to mv square upon r, which is equal to 1 into 1 upon 0.2, which is equal to 20 newtons. Therefore the force will be 20 newtons. Therefore the stress will be equal to F upon A. Therefore the area of cross section A will be equal to F upon stress, which is equal to 20 upon 5 into 10 raised to 6, which is equal to 4 millimeters square. Therefore here the correct answer will be option C. Tension in a metal wire is T1, its length is L1, and when the tension is T2, its length is L2. Its unstretched length is, here are the options. Now, T1 is equal to K into L1 minus L, and T2 is equal to K into L2 minus L. Therefore, taking the ratio, we get T2 upon T1 is equal to KK will get cancelled, which is L2 minus L upon L1 minus L. Therefore, T2 L1 minus T2 L is equal to T1 L2 minus T1 L. Therefore, T2 L1 minus T1 L2 will be equal to T2 minus T1 into L. Therefore, L is equal to T2 L1 minus T1 L2 upon T2 minus T1. Therefore, here the correct answer will be option B. Copper wire and a steel wire having the same cross-sectional area are fastened end to end and stretched by a force F. The length of the copper and the steel wires are in the ratio of 2:1 and the moduli of elasticity are in the ratio of 1:2. What is the ratio of EC upon ES of the extension, where EC is the elongation of the copper wire and ES is the elongation of the steel wire? Now, here E is equal to mg upon L pi r square y. Now if we take everything as constant, EC will be directly, therefore EC upon ES will be equal to LC upon LS into YS upon YC. Therefore we know the ratios of LC and LS and YS upon YC, which is equal to 2 upon 1 into 2 upon 1, which is 4:1. Therefore here the correct answer will be option B. The force constant of a wire is K and that of another wire of the same material is 2K. When both the wires are stretched by the same force, then the relation between the work done in the two cases is, here are the options. Now x1 will be equal to F upon K and x2 will be equal to F upon 2K. Therefore, x2 will be equal to x1 upon 2. Now, therefore, W1 is equal to Fx1 and W2 is equal to Fx2. Now, because W1 is Fx1 and W2 is Fx2, therefore, W2 will be equal to 0.5 W1 because of the above relation. Therefore, here the correct answer will be option B. The company submitted the quotation for building a bridge with the following value of the breaking stress and the working stress expressed in Newton per meter square. Here are the values of the four companies. To whom the contract should be given if all of them have quoted the same amount. Now, the calculation for the factor of safety F for A, B, C and D are as follows. F1 is equal to BS upon WS, which is for A, which is 25 upon 15. which is 5 by 3. F2 is equal to 20 upon 15, which is 4 by 3. F3 is equal to 25 upon 12.5, which is equal to 2. And F4 is 25 upon 20, which is equal to 5 by 4. Therefore, the contract should be given to C since it's keeping the maximum safety. Therefore, the correct answer is C. X is the strain produced in a wire having the Young's modulus Y. Then the strain energy per unit volume is half Yx, B Yx square, C half Yx square, D x square upon Y. Now, the strain energy upon volume or per volume is equal to half into stress into strain, which is equal to half into Y into strain into strain. Since stress is equal to Y into strain, therefore this is equal to half into Y into x square. Therefore, here the correct answer will be option C. The Young's modulus of a wire of length 2 meters and area of cross section 1 millimeter square is 2 into 10 raised to 11 Newton per meter square. The work done in increasing its length by 2 millimeter is, here are the options. Now the formula for work done W is equal to half into y into a into x square upon L. Therefore, substituting the values, we get half into 2 into 10 raised to 11 into 1 into 10 raised to minus 6 into 2 into 2 into 10 raised to minus 6 upon 2. On calculation, we get the value as 0.2 joules. Therefore, the correct answer is option B.